In this video, you will learn how to create in Gnuplot graphs like this one, completely customizing the appearance of the lines. Let's learn how to change the style of the line, changing its color, thickness, and stroke. It will be useful for beginners and also the more experienced because I will show some little-known tricks. In a previous video, we had detailed the different ways to style the display of the legend of a chart. For didactic purposes, we are using a fictitious phase diagram written in terms of the cosine function. Therefore, if you have any questions about the data file used or other topics covered earlier, consider returning to the previous videos of this series on Gnuplot. Link in the description. However, our diagram is not yet visually appealing. We can and will improve it. But we take this moment to discuss, step by step, numerous possibilities of customization of the style of lines. In the file template new, in lines 1 to 3, we define the header, describing the purpose of the code, the author, the creation date, and the last modification. In lines 5 to 11, we configure the terminals, choosing one of them and commenting on the other. We will work with the terminal PNG Cairo, because it is more practical to view the changes in this format. In line 13, we define the encoding for UTF-8. In lines 16 and 17, we specify the labels of the horizontal, X, and vertical, Y, axes. In line 20, we declare the variable date which receives the relative path and name of the data file. In lines 23 and 24, we define the style of the legend. And finally, in lines 26 and 27, we find the command plot.i. Note that no line style was explicitly specified in the plot command. However, when running this script in the terminal, we get two curves connected with different colors. Although we have not defined color, thickness, or stroke, the Gnuplot assumes some default values. But what is this default color? It's easy to imagine a single thickness for all the figures, but how can more than one color be part of a pattern? What happens is that Gnuplot assigns a different line type to each plotted line, following a predefined order. Let's look at it more closely. After the command with lines, WL, we set Linetype 1 for the first line and Linetype 2 for the second line. We run the script again. Surprisingly, nothing has changed visually. Let's invert the numbering, setting Linetype 2 for the first and Linetype 1 for the second. Oops! Now the colors of the curves have been inverted. Do you get a sense of what's going on here? If you do not specify a line style, Gnuplot automatically chooses one for each plotted curve, following a sequential order of the predefined colors. But if there are only 8 default colors, what will happen if we select Linetype 9? Let's see. Strangely, we now only see a single line. That is, the two connected curves have the same color. What has happened here is that the Gnuplot is applying a kind of cyclic boundary condition. If the user chooses LT9, the Gnuplot returns LT1, and if it is LT10, it points to L2, and so on. We can see in this example all 8 colors of predefined lines generated by the command on lines 32 to 35. I used empty quotes to omit repeating the name of the data file, since all commands are using the same data source, which allows the syntax to be shortened. In the other parts of the plot command, I manipulated the data during reading, just scaling the curve for better visualization of the different linetypes. If you were in doubt about this syntax, check out the series of videos that I made showing how to manipulate data during reading, link in the description. If you prefer a monochrome graphic, that is, in grayscale, the Gnuplot offers the option Set Monochrome, which we defined in line 30 of the example script. When this mode is activated, the different lines in the graph will be distinguished by the stroke pattern, solid, dashed, dotted, etc. By default, the Gnuplot defines 6 types of monochrome lines. We can access them by changing the line type, LT, as shown in the following example, lines 32 to 35 of the commented script. This style has some advantages, such as accessibility for people with color blindness. As well, if the graphics will be part of a black and white print, as in scientific publications, because many journals charge extra for color printing, maintaining visual consistency in technical documents. To disable monochrome mode and return to the default color scheme, simply use the unset monochrome command. If this content has been useful to you in some way, consider leaving a like to support the channel. Have questions or want to suggest a theme? Leave a comment. However, let's say you don't want to limit yourself to the default options and want to customize the lines of the chart according to your preferences. Fortunately, this is possible in Gnuplot. Let's start by changing the line thickness, using the linewidth command, abbreviated as 𝑮𝒏𝒖𝒑𝒍𝒐𝒕. A way to change the line thickness globally is in the terminal setting. Initially, the default value for the line thickness is LW1. As we saw, when running the script with this value, the thickness of the lines remains unchanged, since 1 is the default. If we change to LW2, we can see that not only the curves of the graph but also the lines delimiting the x and y axes become thicker. It is possible to reduce the thickness by using values between 0 and 1. However, we can also modify the thickness of the line manually in the plot command style setting. For example, for the first plotted line, after specifying line type LT1, we added the command LW2. When running the script again, we noticed that only the first curve became thicker. This demonstrates that you can use a predefined style, such as LT1, and customize it with additional options. However, it is important to note that the possibilities of using the linewidth command may vary between different terminals of Gnuplot. Moving forward in our customization options, another important aspect of the lines that we can modify is its stroke. As we noted earlier, by default, the lines are displayed solid. However, Gnuplot allows you to change this behavior through the linetype command by specifying the dashed option with the dashtype command, abbreviated as DT, which offers 5 predefined patterns. One of the ways to specify the stroke pattern is through an integer, as shown in the example on lines 44-47 of the commented script. Similar to what we saw with the line types, the Gnuplot applies boundary conditions by specifying a number that exceeds the available tracing options. If the monochrome style maintains a grayscale, differentiating lines by stroke and thickness, what would happen if we reactivate this style together with the definition of a dash type? In doing this, as illustrated in the example, on lines 48 to 51, we notice that the stroke follows our definition, while the color remains in grayscale. However, if the default stroke options still do not meet your needs, Gnuplot offers the flexibility to create custom patterns from the dot, point, and dash styles using an intuitive character syntax. In addition, we can use a numerical representation to define more complex stroke patterns by reporting a sequence of values that alternately represent the length of the solid part of the stroke and the space between the strokes, as we can see in the examples on lines 58 and 59 of the script. Finally, the last aspect of line styling that we will cover in this video is color. We can change the color of a line using the line color command, abbreviated as LC, followed by the name of the desired color in quotation marks, as shown in the example in lines 62 and 64 of the script. It is also possible to combine the color definition with other style commands, as the line type, LT, preserving the predefined thickness and stroke of that type, but changing its color. In addition, we can combine the explicit definition of color with other choices of thickness, LW, and stroke. But what would happen now if we activate once again the monochrome mode, monochrome set, together with the color definition? We can notice, as illustrated in the example in lines 63 and 64, that the lines kept the defined color, but there was a change in the stroke of those lines, for which we had not specified a dash type. Thus, the monochrome mode applies its stroke and thickness settings only to lines whose characteristics were not explicitly defined by the user. However, the universe of color customization in Gnuplot is vast, and we have explored enough for today. We learn how to change the style of a line by selecting color, thickness, and dash. In the next video we will discuss this in detail. See you next time.